Hello everyone. Welcome to Sigmoid Neuron. Today we are going to look at this paper called Enhancing Deep Sort Chain of Thought Reasoning in Large Language Model through Logic. So the paper introduces something called a logical chain of thoughts, LogiCoT. As described by the paper, it is a kind of neurosymbolic framework that enhances the zero-sort chain of thought reasoning ability of the model by using the principle of symbolic logic. So first thing, what exactly is symbolic logic? Symbolic logic is a branch of logic that uses symbols to denote propositions, terms, and relation in order to derive or assist reasoning. Basically, you can say it is a way of representing logical expression by using symbols, variables in place of natural language such as English in order to remove ambiguity. And yes, don't confuse it or don't misunderstand it with the first order logic. You must have had it in college level discrete mathematics course. So this is a kind of thing. First order logic or second order logic is a specific type of symbolic logic. So basically, symbolic logic is an umbrella term for that. And in first order logic or second order logic, they deal with possible values of variables over some domain. They also use additional elements like quantifiers, for example, things like there exist for all. These quantifiers are available in first order logic. So what exactly is logical chain of thoughts? So the idea is to improve the reasoning ability of the language model, particularly in the scenario requiring multi-step reasoning by utilizing their extensive knowledge and establishing a coherent thinking paradigm. So let's look at this introduction part of the paper. So over here they are talking about the success of large language models, and as we all know that large language models have shown remarkable generalization across various tasks, but still have some room for improvement in reasoning abilities, especially in multi-step reasoning scenarios. So LLM often goes through hallucination. Recently, a paper called Reverse Curse of LLM. So if you will ask LLM, and you can even try it with ChatGPT, about something such as A derives B. So for example, if a LLM knows A derives B, and if you will ask it whether B is the derivative of A, it will say it with a lot of confidence, but it fails to understand whether B was derived from A or not. So they found many cases with child-parent relationship of many celebrities. You can check out that paper. So LLM fails to effectively utilize their extensive knowledge to establish coherent thinking paradigm. So this paper proposes logical chain of thought, and the idea is to enhance zero-sort chain of thought reasoning ability of these LLMs. So the intrinsic idea behind it is to number first is think, number second is verify, and number third is revise it step by step. So they came up with something called as reductio ad absurdum. So it is a way to prove what is this. Okay, I will show you that. Yes, here. I think. So this is a way to prove that a statement is false, or to falsify the statement by providing the fact that logical consequence is false. So, for example, the Earth cannot be flat. Otherwise, since the Earth is assumed to be finite in extent, we would find people falling off the edge. So, the premise here is Earth is flat, but the consequence of this premise that the Earth is flat, is that we will definitely find people falling off the edge of Earth, and let's say that is Q. Since Q is not true, and we know that, so we can falsify this statement, or we can falsify this premise P, that P is also false. So this idea is called reductio ad absurdum. And experimental evaluation in the paper demonstrate the improvement in reasoning abilities across diverse domains, including arithmetic, common sense, symbolic, logic, causal inference, and some sort of social problems too. So here is an okay. And let me go to the first page. Yes, here they have an example. Here, if Tom plays football outside and John will also join to play, if John plays football, then Mary won't go outside. Known Mary is outside, is Tom playing football? So what these authors are saying, 9 out of 10 answers from ChatGPT will conclude that we cannot conclude whether Tom is playing football or not. However, this is a very, very simple logical question to ask. Even a kid from class 5 or standard 5 can answer it. But these LLMs fails to answer these kind of things. But when they provided the prompt to ChatGPT with this thing, contrapositive. However, with the help of the knowledge in logic provided to ChatGPT, that contrapositive holds the exact same truth value with the original proposition. So when they asked the ChatGPT to use the contrapositivity, it deduced it correctly. Yes, if John, so it deduced it. If John doesn't join to play, which we have deduced, then it implies that Tom doesn't play football outside. So what exactly is this contrapositivity? Positivity. Okay, I'll write it here. So let's say there is a statement P and it implies something Q. So we read it like P, if P then Q. P then Q. So if P is true, then Q is true. So the contrapositive of this is negation of Q, then negation of P. This is a contrapositive of this. Okay. Moving forward, else. So talking about related work, over here they are talking about the properties a prompt need to have in order to make the logical derivation from the model. So they are talking about relevance, they are talking about decomposition, they are talking about verification grounding, they are talking about diversity, and they are talking about revision. So basically the quality of prompt plays a crucial role in unleashing the power of pre-trained generative language models, or these LLMs, with relevance and decomposition being the most important property. So what exactly is relevance? So basically what it says, when you are trying to get some result from these LLMs, you have to provide it with some very, very relevant prompt. Relevant prompts, or else it will throw an undesired output. Similarly, decomposition is one of the most important property, and here they are talking about the success of least to most approach. So in decomposition, what it says that okay, if an automatic decomposition of tough questions improve the reasoning abilities, reasoning reliability, which has been evidenced by the success of least to most. Basically, least to most is a way to prompt these LLMs. So if you want the model to behave more in a more logical way, you have to decompose a complex or tough question into easy prompts, and it can then it will then give you a better output. So grounding external functions are also a way, such as third-party calculator or information acquisition from other sources like Wikipedia. You can see these things enhances the meaningfulness of generation and reasoning. One good try was Toolformer. So Toolformer was a paper, I think. Toolformer. This paper was around 3-4. It was released 3-4 months back. What they were trying to do, they were trying to generate. They were forcing the LLMs to generate small APIs for these tasks. So for example, if you ask the LLM to calculate 2 plus 3, it will generate an API to calculate this, and this API will return the result as it is filed. And hence, this was a good a good way to approach such kind of problem. By using all these, logical chain of thoughts aims to improve reasoning ability by effectively utilizing extensive knowledge and establishing a coherent thinking paradigm. So, what exactly they are talking about in this paper is they mention the idea that let the model talk. Okay, let the model talk. Plus, let the model think. And if you will give enough time to these LLM models to ask question to itself, and if you will give enough time to these models to think about the problem, it will give you a better results over logical questions. So, as I talked earlier, reductio absurdum is a technique that is used in logic to establish the falseness or invalidity of proposition by assuming its negation and deriving a contradiction or absurdity from it. So it involves making an initial assumption and then deriving a contradiction or absurdity from the assumption, which proves that the original proposition is false. And this technique is commonly employed to establish a claim by showing that its negation leads to contradiction. Therefore, it demonstrates the truth of the original proposition. So, logical chain of thought, what the core idea discussed in the paper. Yes. Here it is. So LLM hallucinates. We all know that, and it really does. It does this very badly sometimes, which means their reasoning procedures are unconstrained by logical principles, which leads to error in their deduction and conclusions. To address this issue, what the authors did, they proposed a verification loop to double-check each reasoning step and identify contradiction in the premise and previously verified thoughts. So for a while, for a while, followed some symbols in context to these papers, and it will be very quite easy for me to make you understand. So just follow these symbols with me. So before explaining this part, I will go with some symbols. So P, in context to the paper, P refers to the known premise or the question context, basically a prompt that is provided as input to the logical chain of thought framework for reasoning. So if in between I'm using this word LogiCoT or logical chain of thoughts interchangeably, just keep in mind that I'm talking about the same thing. Another one is T of I. T of I here represents the reasoning traces or the intermediate steps in the reasoning process of logical chain of thought or chain of thought, you can say. It includes the steps taken by the framework to verify and revise the reasoning process based on principles of symbolic logic. So P is our prompt, or more specifically we can say a premise. Okay, training. Okay. And T of I is the ith step in thought chain. Okay, one more symbol is E of I. This refers to the elimination step in the reasoning trace of logical chain of thought. And for elimination step, a step, and there's one more thing, C of I. So this this refers to the contradiction in the chain of thought reasoning process in this framework. This is contradiction. Step. So okay. Here I will write it again. P is our prompt or premise. T of I is the ith thought and reasoning process. E of I is the ith elimination step. And C of I is the contradiction at ith step. So, okay, wait this with me for some time and everything will start to make sense. Don't worry. So, the verification loop checks the validity of P, and okay, so I need some space. Okay, I'll write it here. So let's say you have a prompt or you have a premise P, and how we can and this P leads to some thoughts in the chain T1, T2, let's say T of I, and how we can take the validity of P, whether P is true or not, on whether we are tracing the right chain in the process. And this could be accomplished by simply applying an AND operation in between. So P tends to T1 and T2 and ... T of I. Right. So basically what I'm trying to say is if P is some premise or it is some prompt and T of I is the step of thoughts in the chain, and if let's say T of I fails the verification process, it implies that the premise and previously verified thought, which were less than T of I, do not entails to Ti. So if this particular step filmed in the verification process. So we can say that if in the chain of thought, if we are coming from here, here to here to here to here, we are not going to enter to TI, and all the previous thought in the chain are not going to TI, and all the thoughts in the chain which are after T of I, that is T of I plus 1, T of I plus 2, T of n say. Now all these need to be revised, so we cannot rely on all these thoughts in the chain to get a better result. And so still, if you are not getting all these, just bear me for a few more minutes and everything will be clear. So the entrance and the core heart idea of the paper is, so they proposed a post hoc explanation. What post hoc means? Overall explaining the entity, overall explanation for an entity which is kind of black box. So they use this approach, post hoc explanation, and this thing comes from chain of thought, and this thing comes from chain of thought, post hoc explanation approach to identify contradiction and compose a post hoc explanation for E of I of T of I. So so we are at our premise. These are chain of thoughts T3 dash 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 T of I, and let's say what if there is some contradiction at this step is not verified. So if this step is not verified, so the contradiction of this premise will be, and contradiction happened at step I, so C of I will be T3 and dash negation of T of I. We can say that another contradiction, C of I equals C of I and E of I elimination step at Ti. So we basically want to eliminate this ith step. To elevate the difficulty in verifying Ti, the author suggests generating a pair of post hoc explanation, that is EI and E naught of I, whether to EI. Okay, so of Ti. So for example, T of I, we found T of I is not verified, and this is the thought at ith step. Okay, so this is the step at ith step, and if it is not verified, so E of I represent whether to eliminate this chain of thought or not, and negation of T of I to check the contradiction of premise. This will be for E of negation of I. So this is trying to say do not eliminate negation of Ti. So this idea of contraposition by checking by generating a pair of post hoc explanation, and by using the idea of contrapositivity, they are trying to verify whether a step in the thought, in the chain of thought, is valid or not. And if it is not valid, it will create a new chain from here. First it will verify this. If it is false, it will create a new chain here, and then it will propagate forward. So here now look at the example and everything will be good. So here is the prompt from the user. So question is, John drives to his friend's house 200 miles away. Friend's house through 200 miles away. He drives at the speed of 70 miles per hour. He had to take a detour that added 10 miles to his trip. after he gets there, he takes a route home that is 240 miles, but he goes 80 miles per hour. Now, when he is returning, he is going 80 miles per hour. How long did the trip take? So let's think the answer step by step. So these things are the chain of thought. So this is T1, this is 2, this is P, this is T3, this is T4. So at the first step, let's try to verify whether first step will intends to the solution or not. So what LLM tries to calculate this from here. First, let's find out how long it takes John to drive to his friend's house. We can use the formula time equal to distance upon speed. So time equal to 2 hour, 2.86 hours. But while verification of this thing, this first T of I, here is our T of I, we generate two post hoc explanation. First one is here, first one is there. So the first post hoc explanation is for preposition, and for second one is for negation. That is for this is this. Now, so step now this LLM is questioning itself. Step 1 is true because the question states that John drives to his friend's house 200 miles away at a speed of 70 miles per hour. Therefore, we can use this formula to calculate how long it takes him to get there. While the post hoc explanation of the negation says step 1 is false, this is false because it doesn't take into account the additional 10 miles that John had to drive due to the detour. So the correct distance that John drove to his friend's house is 210 miles, not 200 miles. Therefore, the correct calculation for the time it took John to drive to his friend's house is 210 upon 70, that is 3 hours. So this negation thing works, and with this post hoc explanation, this is verified. This doesn't got verified, and hence our chain of thought propagated from here. It was supposed to propagate from here to here, here to here, here to here. But after verification process, it got propagated to here. And after verification, it identifies that. So John, to reach his friend's house, John took 3 hours. And now the second question is to find out how long it took John to drive home. We can use the same formula. And John drove 240 miles at the speed of 3, so it's 240 upon 3 hours, and then the total time is the addition of the tour from John's house to friend's house, John's house to friend's house, and friend's house to John's house. So it adds both the thing, and we got the right answer. So this is how at every step it creates a verification loop. It goes through a verification loop, and if we find the need to eliminate a particular node in this chain of thought, we create a new chain, and we propagate rather than propagating from here to here. We will start to propagate from here to here, and eventually we will get a correct result. So let's talk something about experiments. So this logical chain of thought framework. Okay, come here. So this logical chain of thought framework was evaluated on diverse language tasks in various domains, including arithmetic, commonsense, symbolic reasoning, causal inference, etc. So for math reasoning task, they took this GSM 8K dataset, and this dataset contains grade school mathematics questions and AQUA. This is algebraic question answering. Algebraic question answering. Data with advanced questions and multiple options answered and multiple option answers were used in this case. Common sense reasoning tasks include data understanding. Basically, this data set contains is a particular date on this year, on this month is let's say Tuesday. Then what will be the age? So basically, the time difference. And this comes and this data set is used to test the common sense. Causal inference task to test the cause and effect, and this data set was used for emotional unity, social Q&A, emotional and to check emotional intelligence. This social Q&A was used, and next. And these other odd out later objects on these data sets are used. So these are the models on which they tested this logical chain of thought framework, and this where you can see this right mark, tick mark. Here they are using the logical chain of thought. Here they are not using logical chain of thought. So Vicona 7B to GPT-4 they are using, and all these green parts are are in the percentage of result. They found better than the earlier case, that is when they were not using logical chain of thoughts. So looking at this table of experimental results, we can say that upon comparing logical chain of thoughts with zero thought chain of thought as the baseline to demonstrate the benefit of stepwise verification and revision for zero thought reasoning. Out there, again, these things are by what rate they found whether it is going up or not. Why not that? You can look at all these things by yourselves. Meaning the iterations on the and proof of contraposition. So from proof of contraposition, I already told you what is contrapositivity. It is a logical argument that establishes the validity of a statement by showing the equivalence between original statement and its contrapositive form. So you don't even need to do all these, or you can just you need not to go with this complexity. You can verify this with basic truth table by using truth table. So for P, for Q, for P to Q, for negation of P, for negation of Q, for negation of P, take Q. So control this. True, false, true, false, and just plug in the values, and you will always see this will matches. Okay, and here it is now negation of T2, negation of P. So these two columns will match exactly. It will exactly match. And here they are providing the pseudocode for logical chain of thought, and so the first algorithm is logical chain of thought reasoning trees. So how the logical chain of thought reasoning path, how we will trace the path in the reasoning chain of thought. And the second is composing logical chain of thought. Basically, it is a variant of this. So okay, I will explain these algorithms in very short. So It is saying it takes the input premise or prompt, say P, and a large language model. Here is a large language model. So P, and P is for prompt, and LLM is the large language. Sorry, LLM is the large language model. P is the prompt. So LLM is taking this prompt, and it is creating a chain of thought T1 to T of n. The process involves prompting the LLM to generate post hoc inference and verifying them for entailment. So this is the two post hocs, whether to eliminate or whether to eliminate or whether not to eliminate. And if the thought passes the verification, it is kept in the reasoning trace, and if it fails, if it fails, it is revised, and any new chain of thought is generated. Basically, the revision process here, and this is the revision process. This process continues until all the thoughts in the chain is evaluated till the end. The final reasoning trace is returned as the output. Here they are returning as the output. And talking about this composing logical chain of thought, this is a variant of logical chain of thought. Similarly, it is also taking a prompt, and this prompt is being fed to large language model. And the reasoning trace is initialized with the premise, and the LLM is used to generate multiple thoughts T1 to Tn. Based on reasoning trace, the process involves generating inferences using LLM checking for contradiction. So LLM is itself generating the inferences, and it is checking for here it is checking for contradiction, and if the contradiction is found, the corresponding thought is revised, and the process continues, and the final reasoning trace will again return in the end. Apart from that, they have tried a lot of success and failure cases on different data sets when they were using this logical chain of thought. So you can go and look by yourself. This is interesting, and that's all for today. Thank you.